as just the derivative for number 1, y prime. You don't know what you're doing? So you are finding the limit as h approaches 0. What is f of x plus h going to be? Because this, we'll call this f of x. 7, right?
7.
Minus f of x, which is 7, all over h, right? Well, what's 7 minus 7? 0 over h, which is 0, right? So what is the limit of 0 as h approaches 0? Do not overthink this, guys. No.
0 over 0.
No, it's not. There's no h left anymore.
Oh, yeah.
Okay. It's just 0. So y prime equals 0. Guys, some people definitely struggle with this idea of f of x plus h just being 7. Think about it like that's just a horizontal line at y equals 7, right? Make a little graph here for you. You don't have to write this part down, but so if we think about this, that's just that line, right? If I ask you f of 1, what are you going to tell me? 7. If I ask you f of negative 73, what are you going to tell me? So f of x plus h, 7. Okay. So when it's a constant like that, your derivative is always 0. So f of x equals 3. Cool. F prime of x is 0. P of t equals 10. P prime of t equals 0. Y equals 18. Right. Y prime equals 0. And so on and so forth. And guys, the last one there, y equals e squared. E is just a number, right? So that would still just be a constant. Okay? Yeah.
Where's the h going?
Okay, so here, where was the 1 going?
Well, like, the denominator.
Okay, so it's 0 divided by h. What's 0 divided by h? Okay, so that's how you eliminate the h, and then you can go to plug in the h, and there's nowhere to plug it in, so it's just 0. So you're eliminating the h before you plug in that 0. Okay? This is the simplest one, and yet the hardest one for you guys to always wrap your head around. Like, it just seems to...
So they're all 0.
They are all 0, yes. The constant rule. This is your first derivative rule. If your function is a constant, the derivative of that function is always 0. So you wouldn't have to show work. You can just tell me it's 0.
What am I thinking of whenever I see... There was this rule that I thought like 0 over 0 was like 1. I remember seeing that in brackets somewhere. Is that a match?
0 over 0 is the number. That's the oh no, remember? 0 over 0?
Yeah.
Yeah. So you want to simplify before you plug in that other 0. So right here we have 7 minus 7, which is 0, right? 0 divided by h. Simplify that first. So what is 0 divided by h? Okay, what's 0 divided by 7? What's 0 divided by x? What's 0 divided by h? Okay, so we get to this, nowhere to plug the 0 in, it is just 0. Okay. Oh, did you figure
Yeah,
out?
I'm fine.
Okay. Yeah.
Why did you plug in 0
Because then you'd have 0 over 0, which is not okay. So you need to simplify first. Remember how on all these other ones we've done all sorts of things to our equation to get the h's to cancel out so that we can plug it in? Here you need to simplify before you plug it in. It's the same idea. So 7 minus 7 is 0. So you've got 0 divided by h. Do that first. What is 0 divided by h? So now I have the limit as h approaches 0 of 0.
Where did H go? Oh no. Does that start with 7 plus H in front?
No, it starts with f of x plus h. So look at. Okay, so if f of x is 7,
Oh.
you agree with this, right?
Yes.
So there's nowhere to put it. It's still going to be 7.
Okay.
No matter what your x value is, anywhere on this graph, the y value is always 7. Okay? Again, simplest yet hardest to wrap your head around for these. Okay. We can do this, guys. It really does get easy. So are we okay with that? So constant rule, if I ask you the derivative, it's 0 when it's a constant. Okay? All right. Let's try the next one. Maybe. I'm thinking. Okay, guys. So jot down a couple of these. I'm going to write the derivative for all of them for you without you doing it the limit way, and then I want you to come up with what you think the rule is. I know some of you already know it, so please don't yell it out. Give everybody a second to think about it. This is the second kind. And yes, you can do derivatives that quickly. Like, that's just me doing them. That's how simple it is, okay? That's not me having these memorized or anything. It really is that simple once we get to it. You guys starting to see a pattern or not yet? Need a minute to process? You see it? Okay. Hold on. Let's let everybody try to get there. So first, let's look at it. What's happening to the exponent every time? This was a 2, now it's a 1. This was a 3, now it's a 2.
Going down by 1.
Going down by 1, right? You're subtracting 1 from the exponent.
You put the extra in.
Yes, and the original exponent becomes your coefficient. So the 3 goes in front, x, and then 1 less than that is squared.
So what is this?
That's how you find the derivative. So you know how we would go through, this is like the limit? Yeah, this is the first, it's like that first one. If I had done, so that'd be x plus h squared, x squared over h.
That's the answer.
Yeah.
What? So you wouldn't have to do all this.
You wouldn't have to do all of this.
Will you answer some questions so I can actually solve it out?
plug 0 in. You see how that's, I did the wrong one. Where did my 0 go? Oh, these ones. You see over there? So, it's the shortcut for doing it. So, on quizzes, tests, anything like that, if I say find the derivative with the limit definition, when the word limit is involved, you have to do the limit way, the f of x plus h minus f of x. If I just say find the derivative, shortcuts are very happy, okay? Use them. So the only time you have to do the long way is if I ask you to do the limit. Yes?
Sorry, this sounds stupid, but how are you using the shortcut?
Okay. So I am just, instead of going through all of this to get 2x, I just look. So exponent goes in front, then my variable, then 1 less than that exponent. So like this is what the formula looks like. If you start with x to the n, the derivative is n times x to the n minus 1. That's it. Like
How do you use it when you're doing the limit?
no, this is not the shortcut.
Oh,
this is the
okay.
long way with the limit.
Oh, okay, that's
Yeah, I'm saying instead of all of this, you can just write.
okay.
Yeah. Okay.
This is the last time when you
Yep. So only if it says like limit definition in the problem do you have to do the long way. And guys, even if you have to do it the long way, you can certainly check with the shortcut, right, to make sure you get it right. Okay.
Shortcut.
Well, there's all these different rules. So yeah, we have the power rule, the product rule, the quotient rule, so all the different setups. Eventually we'll get to the chain rules. Yeah. What? You had a quest, yeah. Which I believe I got an assist yesterday, so your grade should be sort of updated. Okay. Yes. Enjoy it. All right, so are we okay with power rule? Are you guys alive today? Making it? Okay. Almost. All right, up next. Again, I don't know why that's a blue background, but for some reason it is. So let me jot down what these would be for you. And guys, write down as many of them as you need. You don't have to write everything. I'll do the first 3, and then let's see if you guys can tell me what the last ones are. You can see that okay, right? It's 3x squared plus 3. Oh, the first, like the original one, it's x cubed plus 3x. Yeah, sorry. Are you guys seeing anything? Any pattern here? What do you see, Evan? For each term, right? Yeah, so it's just the power rule for each term. Since we're just adding or subtracting terms, that's what you can do. So guys, just verbally, look at number 4 for me and just tell me, what's it going to be? What's the derivative? 2x plus 7. What about for number 5? Again, just verbally tell me, you don't have to write all of these.
7x plus 7.
By 7x, do you mean 2x?
Yeah.
Okay. do, because the exponent there, isn't that like x to the 0? Right? Like 3 is the same as that. And so if you did 0 times 3, it's gone. Okay.
Oh, and also, it's just a shift up and down.
Mm-hmm. But so the slope wouldn't change. Exactly. All right, guys, and what would 6 be? 6x plus 9x. Okay? So it is the same as the last one. You just find the derivative for each term and add them together. And that is called sum and difference. So all we have left is product and quotient. It's just saying take the derivative for the term f of x. Like each of these is like one little function. So like this is f of x and this is g of x.
Okay.
Yeah, okay. Better than doing the limit for these long ones?
No.
No?
No. No, because I like doing the most.
Okay. You go for it. You can still do them all that way if you want to, but I wouldn't recommend it. Yes.
So in the prime equation, instead of taking the power rule.
It's just like the power rule for each term. Yep. Okay. Other questions? Anybody need more time on this slide? Okay. We're just going to do this one quickly. All right, I'm going to give you the product rule, and then we'll practice a couple with it. Okay. So if we are looking at p of x equaling f of x times g of x, this means you have two things multiplied together that both have a variable in them. Okay. The way we find the derivative, we do g of x, so the second one just as is, times the derivative of the first, plus the first one times the derivative of the second. So we'll do a simple one, but and we'll do one that you could check very easily. They'll get more complicated than that, but let's just do a basic one here. So guys, could you just multiply that out and then use the power rule? Yes, okay, that's one way to do it. We're going to practice with the product rule just so you can see how it works. All right, so do you guys see how this is your f of x and this is your g of x? Ooh, that's a terrible color. I keep picking that color. All right, that's your f of x, that's your g of x. Okay, so let's go through the formula. So it says g of x, well, that's 3x squared, times the derivative of f of x. So what is the derivative of f of x here?
15x squared.
Yes. plus, and again, I'm just going straight from the formula, f of x is 5x cubed times the derivative of g of x, 6x. Okay? So now we just have to simplify. What's my first, what does that multiply to? Good. And the other one? So what's my final answer? Okay. And again, if you had just multiplied the f of x and g of x, you could have done the power rule, you'd get the same thing. But that's a simple one so you guys can see how the formula works. Okay? Questions on the formula? Is there any part of it that you're like, I'm just not seeing where that number comes from? Please ask if you're confused. Yes. So this is the product rule. Okay, so figure out what your f of x and g of x are first. And then just follow the formula. It says g of x. So that's what I started with, was g of x. Okay, times the derivative of f of x. Well, here was f of x. So we've got to use the power rule to find the derivative of that. So that was 3 times 5, which is 15. And then 3 minus 1, which is 2. All right, plus f of x. So there's f of x. And then times the derivative of g of x. So the derivative of this, 2 times 3 is 6. 4 plus 3 is x. And then multiply. Does that help?
Yeah.
Just, label those pieces. Like, if you need to each time, be like, okay, here's f of x, here's g of x, and go from there. Okay? Until it becomes kind of ingrained in your head. Make sure you label those.
Basically, power rule.
Power rule is pretty darn important, yes. You're going to use that within all the other rules. Yes, absolutely. All right. Then we have quotient rule.
That was the last one.
Nope. Last one's coming up. And then we're done with notes. Yeah, so it's like a... No. Notes.
Is there another rule?
So there's more derivatives. There's like the chain rule, but that's not today. Let's see. We'll get rid of some of this. We'll just redo it because I think there's too much written there for you. Yeah, sorry. I just felt like it was too scribbled on.
Oh, okay.
So I'll rewrite it for you. Yeah, no, you had to be that fast. We're done. Didn't you catch it? All right, so we start out with q of x equals f of x over g of x. Everybody knows quotient means divide, right? So now I'm finding the derivative.
I just be confused.
So your numerator here is going to be g of x times f prime of x minus f of x times g prime of x. What does that look really similar to? The product rule. It's the exact same thing as the product rule, but we're subtracting instead of adding. And just think about exponent rules. Division, you subtract. Multiplication, you add, right? Okay. And then it's over g of x squared.
Oh, G of X. Oh, nice.
How it works.
Yes.
I know, sorry. Yeah. Quotient makes sense. We'd have a denominator left in our answer, right? Okay. You can absolutely just memorize that the way it is. Some people like doing it this way, calling your f of x high and the g of x low. So this is low times d high minus high times d low over low squared. Some people sing like a little Seven Dwarfs song with that and memorize it that way, like low d high minus high d low over low squared. But again, if you're like, what, with the lows and the highs, that's completely fine. Just know the formula. Some people really like that, so gotta put it in there. But What?
It's a great. I already memorized it.
It's easy, right? When we do it the same as the product rule, if you like Google Khan Academy videos, they'll do the product rule differently, which is silly to me. Do it the same way as the quotient rule, so you only have one thing to memorize. Okay. All right, so let's try one. So let's say oops, we'll call it Q of X. Let's do x squared minus 3 over 2x plus 1. Do you guys want to try this one on your own?
Yes.
Okay. And guys, look at that. Does that look like that'd be super fun to do with the limit definition?
Yeah.
You know.
I love spending time on
That's good. On
Oh,
tedious
that'd be
little math.
awesome.
Right? Because you'd have x plus h quantity squared minus 3 over 2 times x plus h plus 1 minus x squared minus 3 over 2x plus 1 all over h. Yeah. So use your quotient rule. It's much happier. And again, either think about your lows and highs or labeling as like this is f of x, this is g of x, or this is high, this is low. I don't care. So that would be like sum and difference. So what's the derivative of 2x? And what's the derivative of 1? Okay, so the derivative of that whole thing is just 2.
Is the numerator just 2x?
Yes. Very good. What's the derivative? Okay, so x squared minus 3, isn't that like this? Like one of these?
Yeah. Yeah, I'm saying like not the constant of x.
Oh, okay.
But
What do you mean rid of?
like how do you find the derivative?
Okay, what's the derivative of a constant? That was the very first thing we did.
Oh, 0.
Yes, okay. There we go. And the other way you can think about it, like 3, that's 3x to the 0, right? So then do the power rule. What's 0 times 3? Oh, so that's, okay, another way to think about, like, oh, that's why a constant is always 0. Okay. All right, guys, I'm going to start writing this one out just so I can catch up to you. Do you think I'm going to want you to multiply out your denominator? No, I do not. I mean, Jonathan, I know you like spending time doing those sorts of things, so if you really want to, you go for it. You're done.
Oh, really?
Yeah. You could factor a 2 out of your numerator, and then it'd be x2 times x squared plus x plus 3, but that's not going to factor into anything that's going to cancel out with your denominator. So that is your derivative. Okay? Questions? How are we doing?